Hello everyone, this is HG once again in another tutorial for 3D Studio Max. Recently I saw in Vimeo this here. Actually it is an equalizer and a sinus wave equalizer. The fuzz is connected to the music and also the amplitude, and it will spawn. You will see. Okay, you see it spawn also here. So I tried to mimic something like this or to create. Of course this was not created in 3D Studio Max, but I will try to do something like this. What I will show you in this tutorial is actually the basics, okay, and not all the stuff with compositing and effects around it. I choose a very simple and very boring music, and this will be what we will create. You see, we will have a wave. The fuzz and the amplitude is connected to the music. You can change the music, and when it hits the peak of the fuzz, it will spawn some other particles, and you can do whatever you want with it. Okay, so once again, this will be what we will create. So let's begin. First I create a point and make it 0, 0, 0, and before I do this I increase my timeline to 1000 and right click Curve Editor, and for the Z position I choose Audio Float Absolute from 0 to 100, and I choose audio for this. Close. The next step is another right click, Dub Sheet, Sound, and here add once again my sound here, which will be here. Okay, this is right now what we have. A music that is connected, the Z position of the helper is connected to the music. Okay, so let's begin our work. I go here to particle system and P flow, create a P flow here, and I can make it 0, 0, it's no problem. And go to the particle view. I delete the position, I delete speed, I delete rotation, and I will have just this. Make it very small, size 1. It's up to you. And go here to the PF source, make it frame, and I want to see everything. Okay, and I want to have 1000 particles. So you will see right now nothing here because we have no position. So the first thing is to line out the particle in the X direction. We will create for this data operator. I rename this as a data operator and initial position. Okay, auto update. Okay, so what we want to have here is an output standard, output custom, output standard, which will be our position. Okay, and we need also a vector a converter from real to vector. So another scalar which will be 0. We will have 0 for y and 0 for z. Just we want to have the x birth index, and not just the birth index, another input standard and scale. Yeah, birth size, particle size, habit. Okay, size, and we will say a function real with integer, and we will multiply this. So this come to here, this come to here, this come to x, and we will go here, and instead of tick we will say geometry. So what we have right now here, we lined all the particles in the z x direction. And the next step will be create this sinus wave. For this, create another data operator and rename this data operator, and this will be sinus wave. And we will come here. Here, what we want to have output standard. We will have only. We are interested only in the z component of the position. Okay, so we are interested in the z of the z component of the position, and we create a function, one operator, and I connect this to here, and this function will be not vector, will be real and sinus wave. Okay, here we will have our sinus wave, and here I will create input standard and ID. So each ID depends on the ID that we have here. We will have the ID, and we will make a sinus of it, and we give it to the z position, and you will see that we have already a wave here. So if you come here right now, we have a prefactor. If you increase or decrease this, you see that there are two things happening. First, this is the frequency. We can increase or decrease the frequency. I make it a very low frequency. Okay, and the next step is this. If I decrease the post factor, you see that I am changing the amplitude. Okay, so instead of changing it from here, I bring it back to 1, create another function here, and I will say this function will be real, and excuse me, multiplication, connect this to here, this to here, and the scalar here, and I will connect this to here. Instead of have it here in the post factor, we will have it here. So this will be our amplitude. Okay, we have right now our amplitude, which will be the post factor. We have the frequency, which I want to have it fixed, and also if instead of just having a birth index here, we create another function here. and make it real, and create another scalar and connect this to here, and connect this to here, and connect this to here. What we have here, we are making an offset. It's a fuzz, you see. You can see it right now. So we have a fuzz with increasing and decreasing this value. We will have a fuzz. So that is wonderful. So instead of having these two scalar here, I press 6. I create another data operator here, and I rename this to data operator initial values, and I create an input standard which say new event, and output new, which will be a global and a real, and a scalar, which will be of course 0. While this when I rename this to the first, I rename this to fuzz. Okay, this will be our fuzz, and just in the first event, just make a new event. When in the first frame it will be created this variable, and the value will be 0, and after that we can change it. Okay, no problem. Select it, make sure it's global, and select all of them, and right click, copy and paste. We create another variable, and we rename this one to pick. Okay, and I create also another one, make it copy, make it paste. This one I want to have this rename spawn test. And this should not be real, this should be boolean, which will be false at beginning. Okay, so we created 3 variables, so we can select them and group them also. Sorry. And here I select here, and this is execution order 1, 1, 1, 1, 2, and 1, 3. That's okay, that's wonderful. We go back to our sinus wave, and instead of these 2, here we will have our fuzz. Okay, input custom we will have here, and will be our fuzz. And instead of this one, we will have another input custom, and this will be my peak. Okay, the amplitude. But right now it will have nothing, because the value is of course 0. So how we can do this? We came here, put this here, and let's create this. I create a select object. I select my object, which is my point. Okay, and I will get the object object pivot, and this will be a vector. And what I want to have from this vector is convert vector to just the z. I'm interested in the z, so I get the z of my my helper, and I connect it output custom, output new. No, I have it. Sorry, output custom. Yeah. So this will be our pick. Okay. So we will change it after that. Okay, no problem. And another one that I want to create for fuzz will be very easy. Create an input custom which will be my fuzz, and an output custom which will be also my fuzz, and another input custom which will be my pick, and a function that will be real and multiplication. So with changing the fuzz, we will add this fuzz to with changing the peak, we will add the peak to our fuzz, and we will have new fuzz. And make it drop here. So close this and see the result. That is good until now, but the point is this: I want to have like an equalizer that when it's in the top, it should go in the top, but I don't want to have it come as very with a high speed back down. I will have them in a high amplitude and let them come down slowly. Okay, for this I will do something like this. I will say here we will get the z position here, and say pick another input custom, and we will have our pick, and say okay, condition, if this value, if our current z value is greater than peak, so if it just indicates that it's greater, then do this. Okay, so if it's not greater, do it, don't do it. And I select the whole stuff here, copy and paste here, and we will say here delete it. So what if it's less? What if it's less? If it's less, then an input custom, we select our pick, create a scalar and a function which will be real. And what we want to do here is subtraction, peak -1, and make a pipeline here and say float. Okay, okay, R2 if R1 is less or equal to 0 is, so R2. So I create another scalar here. Don't be confused, I will explain all of this. So make it R2, this will be R2, this come here, and this come here, and this come here. So what we want to say here is this: we will get the position, the z position. If the current z position is greater than the current peak, so the peak number will be this one, okay? But if not, so we wanted to have the wave come down in a slower way, okay? If not, we will check it once again here. If not, if it's less, so in this case, get the old number, the old peak number, and make it subtraction to 1. So if it, for example, 35, make it 34, and we will have it at this. Check it. If this number is less than 0, we don't want to have it minus, okay? So stay on 0. If it's greater than 0, so put this number in the peak. So here we will say, here we have here R2, which is 0. If R1, which is this R1, less or equal to 0, and R3, which is the same, this number, if R1 is greater than 0. So what we have done here is exactly this. So I close this and I close this and check it what we have created. Aha, you see? It's very beautiful. Okay, the next step is creating the spawn test and creating spawn. Before do this, I'm going here and say input output custom, and we will have it spawn test and scalar, which will be boolean here true, okay? And I select both of them, copy and paste, and select these two files. Okay, in this case here, if it's greater, so it should make it, this is a filter, make spawn test true only if this number is greater, in this case, okay? And in this case, make it false, make the spawn test false if it's less. So just in the peaks we will have spawn test true. So what we can do with this spawn test, it's very easy. We create another data operator here, and of course first thing is to rename it data operator and spawn, and we say make a spawn as additive, scalar 1, make it integer. So spawn particle, just in case that input custom, just in case that our spawn test is true. So easy. So we will have some spawn here, but it will be the same, you see here. Because we connected to the, here in the initial value, we told, no, not here, in the initial position, we connected here to the birth, the x value, so it will create spawn particles, and these particles will come in front of. Pretty good, huh? So, but we don't want to have them like this. What we want to have is, so we know the first 1000 particles are our line. So I create here an data test and say go to the next event if input standard, if the IDs, if the bit index are go to the next event if the birth index is greater than 1000. So the new particles will go to the next event, and in the next event what we will have is a random walk, a little bit speed, and you can change it whatever. The tutorial is about this sinus wave. The other stuff is pretty easy, and it's up to you how to work with it. Create an edge test and make a delete. So, and of course go here, instead of ticks have it to geometry. So let's play. So this is the end result. So you can change the music. Once again, we created here the whole tutorial is about this sinus wave. This is the heart of this function, this sinus wave, which we will have three parts. The prefactor here is the frequency, which we will have it here in a constant value. We have a phase here, and we have a peak, and here we have connect these three values, these two values here in the initial values to our music. So this was the tutorial about. I hope you enjoyed this tutorial and you learned something. If you like my work, don't forget to subscribe. If you have any other question or idea that you want to create and want to ask me, don't hesitate, contact me, connect and ask me. I think that is for today. Have a good day. Bye.